Hey, good morning. Bob Desmond here. Doing part 6, a continuation of how I fit my top and get the proper relief, proper neck angle, we should say, or top angle. And okay, just to recap, here's the top. I have already planed these sides. If you follow the other 5 parts of this little series, these sides have already been planed and they're all ready to receive the top. Now I do have to glue in the curved liners, this stuff. This will get glued in and I'll be doing that today. My wife and my daughter are at the beach having a good time over at Port Canaveral, and I'm here working on a guitar. So I wanted to talk about a couple of things. So the next step, now that I have these sides angled from about -1.5 from the 0 line here, and -3.5, -3 here. Was it 3? I can't remember now. Yeah, 3.5. 3.5 here, -3.5 here, and -1.5 here, okay? So it fits well now, okay? And it's close enough at this moment to glue in the kerfings. The final fitting hasn't been done. When I glue the kerfings in, I'm going to glue them slightly higher than the sides, okay? And then I will I'll chisel and sand them down. I'm talking about a 32nd of an inch higher, no more than that, okay? All right, now, one of you listeners out there has asked me a lot of questions, and I think even though this isn't a professional video, I think what I've been telling you all is pretty thorough, but apparently not thorough enough for this one gentleman. So I'm not putting him down. I just want to go into this. When I make a top, I put a 2-degree dome in it. When I glue in the braces, I glue it in a work board that is scooped out 2 millimeters. It's scooped out essentially. The scooping out starts right about in this area, just above the bridge, and it kind of spreads out. So the deepest part would be 2 millimeters. So essentially this top has a 2 millimeter dome. It's 2 millimeters it's 2 millimeters higher in the middle than the sides, okay? Which presents another little issue. And I haven't gone into this yet because we didn't get to part 6 yet until right now. Okay, so if this is a little bit higher, then obviously the top is curving a very slight amount. These sides are probably 1 millimeter, maybe a little bit less, below the 0 line, okay? So because of that, even though I get the 0 line established, even though I get my new line, my new plane established, I still need to remove, and I won't do this until after the kerfing is in, I need to remove a little bit more here and here, and essentially here and here. The waist will be the highest point on this new line, okay? Right now it's all on a straight line, going from -1.5 here to -3.5 here from the 0 line. Because of the slight doming of the soundboard, okay, now there's something else up here which I'll tell you in a minute, which will really confuse you. But I will lower these sides, especially here, by about no more than 1 millimeter. This will remain, but where the sides come down and go into where the top comes down and goes into the sides here, because it's domed, these will be a little bit lower. Not this will be higher, but I'll take a little weight here and a little here. It's immeasurable. I do it with my eye. I've been doing this for a long time. And I use a sanding stick to sand it, or I might use my little brass block plane to take off a few sweeps, okay? And it's all done by eye. It's not, Desmond Guitars isn't a factory. It's a human being making things by hand. So as much as I try to do everything the same on every guitar, because I'm a human and it's not a factory, they could all vary slightly from one to the next, okay? Now I'm going to share an important tip. And I learned this from the son of Manuel Velasquez. One day I was over there at the Velasquez workshop, and Manuel's son, Alfredo, showed me a tip. One of the things that they do, because of the neck angle and the body angle, one of the things they do is this upper harmonic bar, they make it convex, whereas the harmonic bar is, excuse me, I want to go back. Just the opposite. They make this bar concave while this one is convex. Okay? Now, I don't know anybody else that does this, but I do it. I learned it from them, and they shared that with me. So, why do I do that? So keep in mind, this bar has a slight convex dome to it. Where it glues to the top, the bar is convex. This bar, when it's glued to the top, is concave. Why? Okay, well, I'm going to hold this upside down for a moment. Actually, I'm going to put it back on this way. So, here's the top, thick top. It's 3.5 millimeters thick down here. 3 millimeters thick. Excuse me. I'm getting myself mixed up here. Yeah, it's 3.5 here, and it's the same here. Excuse me. It's 3 millimeters down here, but in this area, it's 3.5, and up here it's 3.5. It's a little thinner here around the edges. Goes down to about 3 millimeters on the edges, the periphery. Okay, so the reason for making this bar concave is by having it concave, the top gets glued down into that concavity. So in other words, when I glue this top right here on this shelf, when I clamp that down, the clamping pressure in the glue is going to pull this down. And by having this bar concave, the angle will continue to go low here, okay? And because we have a big hole right here, the top is essentially going down a little bit, and then it's transitioning and going back up right here, okay? Now it's only going up a little tiny bit, okay? It's not going to change the world, but the idea here is by pulling this down, when I glue the fingerboard on, this is all one angle. In other words, when you get to when the fingerboard gets to the 12th fret, I don't have to remove much wood at the bottom of the fingerboard to fit this angle. It's pretty much on a straight line because of the concave brace, and because this is going to get pulled down when it's glued to this shelf. Okay? So that's the big news. This brace is concave, and the bottom brace right here, the harmonic bar, is convex. It's domed, where this one is reverse domed. okay? And the reason for that, of course, is to pull, to end up with a fingerboard that doesn't have to be substantially planed on the bottom to fit the angle here. I had a guitar in here one time by a young maker, and I'm not going to name his name, but I will tell you that his father is a famous guitar player, and he's part of a big family of guitar players on the West Coast. So you can figure that out. And this famous guitar player, his son is a luthier, and he's actually built more guitars than I have. He's probably built 3 times as many. Anyway, one day I had one of his guitars in the shop, and it had a big hump right here. In other words, it wasn't flat and it wasn't concave. It was actually domed right here. That presented excuse me for the French, a shitload of problems in the geometry. And I called him up with the client here, and I said, so-and-so, hi, this is Bob from Orlando, and I got one of your guitars here. And he said, hey, Bob, how are you doing? And he knew who I was, and I knew who he was. And I said, listen, I'm just calling you to confirm that you did this on purpose. Do you put a dome in the upper bout underneath the fingerboard? And he said, yes, that's not a mistake. That's what I do. And I said, okay, great. I just wanted to confirm that. Hope you're doing well, and I hope your father's doing well, and, keep up the good work. And then I hung up the phone. And I looked at the client, whose guitar I had here, and I said, even though he thinks he's doing it right, it's really wrong. It presented a whole bunch of geometrical problems, and I won't go into them all. And essentially, I told this owner of this guitar, I said, if I were you, oh, and by the way, this was like guitar number 120. So, it wasn't one of his first guitars. He'd built over 100 guitars. And so the deal is, you don't want to hump here, because that's going to give you a nightmare. And the great Manuel Velasquez and his son, Alfredo, taught me not to do that, to actually pull the top down here. And because you have a big sound hole, you can transition the top. It's not going to be under any great stress because you already got a big hole here, so it's really easier to manipulate, okay? So I hope you understand that. That's all I want to say here. I'm going to spend the rest of my morning, and it's actually almost lunchtime. I'm going to spend the rest of the afternoon gluing and kerfing and getting this guitar to the same place as the other guitar, so that they're both got the curved liners in and everything's ready to fit the top and the back, okay? Actually, the backs are already fit on both of these guitars. So today's lesson was simply, I'm a human being. I use my eye. I only have one right now. This one's all blurry. And that's another story. I went to 2 specialists last week, and I actually found out that I have a optic nerve problem with my right eye. And I also have a cataract or a cornea issue. So I'm not sure where all that's going. But while I still have one good eye, I'm going to finish these 2 guitars while I can still see, okay? So the lesson today is twofold. One, I've got these sides now playing the way I want them. From the 0 line, which we already talked about, minus 1.5 millimeters here, because the top is only 3 millimeters thick here. And here, minus 3.5 from the 0 line, because the entire top has to fit down in there and come out flush with the neck, okay? And the other thing is This bar is concave. In other words, going this way at the where it glues to the top, it's curved. 1 millimeter, just a little bit, not excessive, just a tiny little bit. And this bar has a 2 millimeter dome to it, essentially a 2 millimeter dome. It's convex, and the convex surface is what's glued to the top. Okay? And we flip this thing over, and I make sure I'm on the center line here, and I make sure I'm on the center line here. I have my mirror here, and my center line is underneath, so I can see it in the mirror. Essentially, once I get the kerfing in and shape the kerfing, this top is ready to glue on. I will do a little bit of, like I said, I'm going to lower this a little tiny bit here. And these too, I already did this morning. So I already took these down. I'll lower these a little bit once the kerfing is fit. Okay, that's today's lesson. It's going to be 96 in Orlando today. I went for a 2.5 mile hike through the woods this morning early to get my exercise in, slowly recuperating my legs, I had a couple of problems. And yeah, it's going to be really hot this afternoon, so I'll be in the swimming pool, hopefully, after I get these glued in. Okay, Bob signing out. I hope you understand some of what's going on here. But keep in mind, it's not a factory. If it was a factory, it's not set up for a factory here. This is a one-person, human being operation. I strive for perfection, but it's impossible. Perfection is impossible. Now, all these things that I've done will lead me to my final action of 3.5 on the 6th string, 12th fret, the gap between the fret and the bottom of the string. I'm shooting for 3.5, and on the first string, I'm shooting for 2.6, 2.7 millimeters from the top of the fret to the bottom of the first string. And with a bridge saddle of 12 millimeters. And yes, it's high, but that's where I start, okay? One other thing, when I make my bridges, my tie block is angled slightly toward the treble side, okay? And a lot of makers do this. Hauser does it, Ramirez does it, and Desmond does it, and a lot of other people too. Further lowering the first string and all the other strings slightly. These first, the 1, 2, and 3 strings, they don't travel in a giant arc, so you can make them lower to the fretboard. Whereas 6 and 5 and 4, they travel in quite a large arc when you pluck them. And of course, you need a little bit higher action there. And I'll possibly go into that when I glue the fingerboard on and show you all that stuff. But that's not going to come for quite a while. So don't hold your breath for that video. Okay, Bob signing out, and I hope you all have a great day. Today's Monday, the 28th of July, 2025. Thanks for watching.